We're continuing with our unit on logic and geometry basics with basics on segments and congruence. First, we need to start by taking a look at some undefined terms. In geometry, we define terms using words we've already defined, and there are three words that are not formally defined. These are point, line, and plane. There are certain characteristics of each. A point has no size or dimension. It represents a location and is named with a capital letter. So in our line over here, we have points A and B dotted on the line, named with a capital letter. In a line has no thickness and is only one-dimensional. It extends infinitely in both directions with arrowheads. So again, if we look at our line, we see the arrows indicating that it's going on and on and on forever in both directions. We name a line by 2 points on the line. In this case, line AB. Or we can use a single lowercase letter. We can also call this line L. Through any 2 points, there's exactly one line. So if we were to draw 2 points on our page anywhere, here I have 2 points, there's only one line that I can draw that is going to go through both points. Now keep in mind the line is straight. Mine was a little wonky there. But again, if I draw 2 points, I can only connect them in one way. There's only one line that goes through those 2 points. And the third word we're going to define is a plane. It has no thickness, but goes in 2 dimensions. It extends infinitely in all directions. So this is going here and there, here and there. It's kind of like a big flat piece of paper. It is defined by 3 non-collinear points. Non-collinear means that the 3 points do not form a straight line. So when I look at this plane, there are only 3 points that are dotted. So I can name this plane ABC. I could name it CBA. I could name it ACB. Any combination of that. We name it with 3 points that are non-collinear, or we could also use the lowercase letter. This is plane M, and I guess that should be lowercase m. If we have 3 points that do form a straight line, then this is going to be a line. It's not going to be a plane. We need 3 points that do not form a straight line. Then we can say they all lie on the plane. We have 2 other defined terms, segment and ray. A segment consists of 2 endpoints on a line and all the points in between. So this is segment AB, and all of these little points that I'm putting on here in orange are also contained or included on that segment. A ray, and in this case we have ray AB, consists of 1 endpoint and all the points on that side of the line. So ray AB, we would name it as AB. A is the starting point. It's the end point, and then B comes after it. In this case, I would call this ray BA. B is my starting, or in this case, end point, but it has that solid dot on it. Opposite rays are rays that go in opposite directions. They are collinear, and we want to be careful on how we name it. We have a line, maybe we call it line AB. There are 2 different rays on line AB. C is an endpoint in this case, and we have ray CA, but we could also have ray CB. Notice they share the endpoint of C but go in the opposite directions, and they form a straight line. Opposite rays are collinear. So I can't have a ray that looks like this, or I can't have opposite rays that look like this, even though this is C, maybe this is point A, and this is point B. I can no longer call these opposite rays. CA and CB in this example are not opposite rays because they are not collinear. We have an example where we're going to give certain points or names to this specific drawing. It says give another name for line EF. Notice in the notation, EF has the little arrows above it showing that it's a line going on and on forever. Give another name for line EF. Here it is, EF. We could also call this line M. Name 3 points that are collinear. We need 3 points that are in the straight line. I think we've got C, then E, and D. These are all collinear points. This is name 4 points that are coplanar. What does coplanar mean? Coplanar means that our points are on the same plane. So think of a plane as a piece of paper. Which points are on that piece of paper? Well, we've got C, we've got E, we've got D, and there's another one, B, that is also on that plane. Give another name for segment EF. Notice the notation doesn't have arrows on either side. This means it's a segment. So EF, here's segment E to F. Give another name for segment EF. We could call it segment FE. Because it doesn't have, it's not a ray, it doesn't have a certain endpoint that you have to start naming it with. Name a ray with endpoint E that is an opposite ray of EC. So if I have a ray with an endpoint of E, I know the name has to start with E. I need it to be the opposite of EC. So here's EC going in this direction. The opposite ray, which means it needs to be in the same line, will be ED. And we notate that with an arrow headed to the right side. This also indicates that E is your endpoint. We can have intersections. Intersections, 2 or more geometric shapes intersect if they have 1 or more points in common. Anytime we have 2 intersecting lines, they intersect at a point. Line M and line N intersect at point A. When 2 planes intersect, they intersect at a line. So the red plane and the blue plane intersect at line Q. These dotted marks are showing you the extension of the plane kind of behind, like this is the back top corner of the red page right there. And this here is the back edge of the blue plane. So those dotted lines are showing you like the back end, what you can't see. Name the intersection of line KL and PQ. K to L, here's KL, and then we have PQ. Here's PQ. They're lines, so they must intersect at a point, and where I can see that point of intersection is right there at point J. Name the intersection of plane R and plane S. Well, remember, plane R and plane S, when 2 planes intersect, they intersect at a line. So I'm going to go ahead and draw my line notation, and we have to figure out which line they intersect at. Plane R is like my white plane that's going horizontally side to side, where plane S is the gray plane, and that's going vertically up and down. So the line that they intersect at is right here. And we can call that line MN. You could also call it NM. You could call it JN or JM. Name 3 pairs of opposite rays. Remember to name your ray starting at the endpoint. So if I go here, JM, that's 1. Its opposite ray is going to be JN. We can also start with J and go kind of up to Q, JQ. Its opposite ray would be JP. We also have JK with its opposite ray, JL. And again, make sure you're naming your rays by the endpoint first. We have some other vocabulary: axiom, postulate, conjecture, theorem. Conjectures are not proven false. Axioms are obviously true. Postulates are assumed true, and theorems are proven true. We use most of these and definitions to deductively prove new theorems. And we have 2 postulates that we're going to look at. Postulate number 1 is the ruler postulate. The points on a line can be matched 1-to-1 with real numbers. So think of your number line. If you put a line right on there, you've got points on the number line that fit with this. And we can do the same thing here. The real number that corresponds to a point is the coordinate of the point. Keep in mind that distance is always positive. Between points A and B, written as AB, is the absolute value of the difference of the coordinates A and B. So when we're thinking about this, we have 2 points. These are the endpoints of our segment, and we want to find the distance between the 2. I'm taking the second point and subtracting the first point, but also taking their absolute value. We have a second postulate called the segment addition postulate. If B is between A and C, so here it is, B is in between. It's not right in between, it's just on the line in between A and C. If we were to take the distance between A and B and add it to the distance of B to C, we would get this full length of A to C. Vice versa, if we say, oh, let's add AB plus BC. A to C would be equal to AB plus BC. That tells us that the B is in the center of A and B. Not in the center, but in between A and B. And notice that B is written twice in this addition postulate. So we have some examples. Go ahead and find KM, UV, and LM. When we say find KM, we're meaning find the length of KM. And you have this little notation on your notes to indicate that. So we want to find K to M, which is this full distance. Using our segment addition postulate, if we know that K to L is 24 and L to M is 12, we just add them to get our length. For B, it says find U to V. Well, that's not the full distance. It's just a little section of it. If I take the full distance from U to W, which is 56, and subtract the distance from W to V, I'm subtracting this distance away, subtract 45, we'll get the length of UV, which in this case is 11. Now, letter C involves some variables, but the process is the same as letter B. We know the full segment is 22. and I'm going to subtract LM, which is just 3x. And I can set it equal to the value of KL, which is going to be x. Some students set it up that way. Other students will say, well, segment addition, I know that x plus 3x should equal the full length of 22. You can do it either way. It's up to you. So if I was doing this setup, I would add 3x to both sides. We want our variables on the same side. And then I would have to divide by 4. And I'll get the x to be 22 over 4, which you can reduce to 11 halves. That's my value of x. I'm going to put that in here. It's 11 halves. If I'm working on this side, I'm going to combine my two variables. They're already on the same side. And again, divide by 4 on both sides. And we're getting the same thing. So you can set it up either way, and you get 11 over 2, same thing. Now, it's important to double check to make sure you've answered the question. We now know the value of x is 11 halves, but it says find LM. So we need to figure out what LM is. Well, we know x is 11 halves, so if I want to find LM, I'm just going to replace the x with 11 halves. And remember how to multiply fractions. I multiply straight across the top, straight across the bottom. Maybe I put a little 1 under that 3 to help. 3 times 11 is 33. 1 times 2 is 2. And that's our value for LM. Go ahead and pause the video and you try these. As you're working, hopefully you found your answers to be 42 for XY. For VW, our value is 14. And for ST, our value is 23. So again, we're doing this. For here, I need to find VW. I can do it 2 different ways, but this is probably the easiest way, taking our 2 segments to add them together to equal the full segment. We'll get our x value to be 6. We have to take our x value to plug in here. So we're doing 6 plus 8 to get the 14. Same thing with this last one. We need to find ST, which is this. We know a bunch of things here. We know that 7x minus 8 plus 3x plus 5 is equaling the full length of 8x plus 9. I can do some combo of my variables here. I can work with my integers there. I can start moving my variables to one side. I can move my constants to the other side. Maybe I need that line down. When I subtract my x's, I get 2x. On the other side, they cancel out. Here I have 12. When I divide, I get my variable to equal 6. But again, I need to find the full length, so I'm going to take my 3, plug in 6, and add 5 to it. 18 plus 5 is 23. The last little thing we want to talk about today is comparing segments for congruence. And this is kind of like that ruler postulate. You can put a line segment on a coordinate plane by using the ordered pairs. So we're going to plot these. J is -3, +4. When you plot your point, make sure you label it. K is 2, 4. L is 1, 3. And M is 1, -2. When your line segments are horizontal or vertical, it's very easy to figure out the distance. So it says determine whether KM and LM are congruent. So here's KM and here's LM. With them being horizontal and vertical, I can just count the length. So for J to M, it is 1, 2, 3, 4, 5. I'm sorry, that's J to K. J to K's distance or length is 5. L to M, I can just count again, 1, 2, 3, 4, 5. L to M is also 5. Therefore, because their lengths are the same, segment JK is congruent, and this is the symbol for congruence right here. 2 lines with the tilde above it. JK is congruent to LM. Take a moment to remember what congruent means. Congruent means it has the same length. So these two definitely have the same length, therefore they are congruent.